I think we should be alive by now. Um, Let me see. What are you doing today? So we're going to be starting the third project. I'm going to be starting the third project since I started this whole uncertain systems thing. Like I started by basically approaching quantum computing from scratch. This is like quantum. I think I called that project Quantum Computing 0 to 1. So I basically kind of wanted to learn quantum computing from the ground up and get to a point where you kind of feel comfortable, you have like a basic understanding of what's going on there, right? And I think that I achieved that goal. It took almost 2 years worth of video, to be honest. And not a worth of video, but like a 2 years sort of time frame. Um, like 300 hours plus of videos. It's the you can find all the journey in the YouTube channel. Quantum computing. No, what am I saying? Uncertain systems. So this is, just to give a bit of context, this was kind of the first, what I then packaged as the first project of this whole thing, right? So um, if you go here, I'm not subscribed to my own channel. Should I? I don't know. Anyway, so there's the Quantum Computing 0 to 1 series, which I'll probably work on a better organization, but it's basically a bunch of, it's just me learning quantum computing. That's the whole point, right? So this is like a ton of videos of me just going from the very basic, like I have no clue what I'm doing, down to like, and this is really goes from 2019 to like 2020. Um, I think the 4 was for the fourth quarter, I think. So, 48 videos, 84 videos, you see, it's a ton of videos, right? So this was the first project. The second project that I'm still closing up is the entanglement hypergraph thing, which is actually not called that anymore, but basically I kind of then moved on to, build these it's sort of a tool, like a Python library that would allow you to explore a system in a bit of a different, non-traditional way. So you could kind of maybe visualize entanglement, take a look at interference patterns. And it was a bit of an exercise of, let's put everything that I've learned about quantum computing in the past years into, building a tool that actually challenges the understanding, core understanding of the whole thing, right? So you have to figure out how to I had to figure out how to simulate certain things, how to implement measurement, how to implement post selection and stuff like that. This is all, it's almost there, it's almost ready for launch. It's available as an open source project, and as I call the package ANSYS for uncertain systems. And I'm going to be I'm going to be, finalizing these a bit off stream because now it's more like the polishing and testing side of things. So I might do occasionally a couple of streams here and there where I talk about this stuff, but, I kind of wanted to move the focus of the streams a bit more towards the third project, which, which is the one that I kind of want to kickstart today, which is basically learning quantum mechanics from the ground up. So kind of moving a bit, you know, um, just going a bit away from the quantum computing bubble and just kind of taking a look at quantum mechanics a bit more, a bit more, concretely. So it's just not just kind of, stay within the quantum computing world where you don't care so much about the underlying physics, but like rather say, look, let's take a look at the actual underlying physics of what is all this based on, right? So that will be the third project. Um, and I'll be hosting the videos. I'll be putting the archived videos in the YouTube channel as well, but it'll be all live streams. And the concept will be we'll be learning all this from scratch and live. So yeah, basically that's kind of a bit of the context in here, right? So it's not that the whole thing here is just going to disappear. That's something that I'm really committing to actually maintain long term and really develop farther, just as a toy tool for me as well to learn as I build this up into more complex, I have more complex functionality into this. But now the idea is, how do we learn quantum mechanics from the ground up? That's the main question. I do have an idea of a potential way to do these, but I wanted to use the stream today to kind of take a look at Google a bit and see whether there's any other ways around that people suggest you could learn that. What I'm not going to do is I'm not going to go back to university. I want to do these live on the internet just with what's available out there and kind of try to prove that you can actually learn quantum mechanics um, to a good level, hopefully. And probably a lot of people will just be making fun of me, but we'll see. We'll see. We'll see. Um, First of all, let me see. Let me see if I got this whole stream stuff going on and it's working correctly. I'll just do a quick share in Twitter. I did say that I was going to do this, but you know, so join me as I figure out how to learn quantum mechanics, quantum mechanics um, live and only using the internet. It seems a bit stupid, but uh, you can really learn everything on the internet nowadays. It's yeah, definitely gonna be a fun journey. So let me just link that. So this is twitch.tv/ uncertain systems, I think it is, right? Does it pick it up? Uncertain systems. Is this the real thing? I don't know if it picks it up. So Twitch uncertain seas. Okay, yeah. And I mess with my usernames. Yeah, there you go. Cool. So, well, how do we do this? I mean, I know I'm probably already a bit biased, but one of the ideas that I had, which is a bit crazy, is to actually take a look at Wolfram's project, right? It's I know that a lot of people are just giving rather bad feedback about these, but there's no I feel there's no better way to kind of learn something than just by trying to rediscover it. And I think that's essentially what the project, the Wolfram's project, is trying to do. And you can, they might be totally wrong, and this might be totally the wrong approach, but it puts you in uncertain land. It puts you in a situation where you cannot trust what you're learning. And I think that is a great way to learn when you have to challenge what you're learning, right? It's not that you're reading something like, oh yeah, I can trust the source. I can trust that because it's that professor at the university. It's that well-known book. It's that well-known course online. Like learning out there in the wild comes with this uncertainty of, am I learning the right thing, or is it someone just bullshitting me, and I'm just learning the wrong thing? And then I think that's why I think that taking a look at Wolfram's project could be an interesting way to do this. So Wolfram's physics project, and that goes beyond quantum mechanics, but there's a whole bunch of, as far as I know, and I've been watching some of the videos recently, there is, the concept here is, yeah, there's a bunch of stuff that's around classical mechanics, and in general it's about trying to find the fundamental theory of physics, which I'm definitely not interested in, but that would be cool. But there's, what they're trying to do essentially is they're trying to, from an abstract model, try to map like to actual physics, laws and stuff. And so one of the things they're trying to do is trying to see if they can somewhat map that model to quantum mechanics. And so this means there's a lot of work being done in the project that is around, yeah, kind of mapping quantum mechanics to these. And so it's a great way, it's a great excuse to then take a look at these and try to learn quantum mechanics on the go at the same time as, I don't know, following I don't know if it's a project you can just follow. It's something you can kind of get your hands on, play with some tools or whatnot. Um, there is a, and by the way, a shout out to the Icon Bros, who did like a video recently on these, which actually got me a bit motivated into kickstarting this project a bit earlier than I actually had planned. But this is one way to do this. But I don't want to be. I want to give other ways the chance. I want to just go and take a look at what Google tells me. If I say how to learn quantum mechanics. So what is it? What is it? In order to study elementary quantum mechanics, you must ideally have an understanding of the following mathematical ideas: complex numbers, yeah, kind of, partial and ordinary differential equations, no clue. I mean, I know what they are, but like I really have not studied that in depth in terms of how to solve these things. Integral calculus 1 to 3. Yeah, calculus, algebra, Fourier analysis. I know what these terms mean, but I've never really. So this Wikiversity, what is these? Quantum mechanics. Is quantum mechanics easy to learn? Quantum mechanics is deemed to be the hardest part of physics. Systems with quantum behavior don't follow the rules that we're used to. Yeah, but that's like news something. Is Russian University or what is this? Um, oh, look at these. That's definitely because I want to take some notes in terms of kind of what's the roadmap, right? Like I was missing a word. What's the how should I approach these? So what's the standard roadmap to learning quantum physics? Um, is there something useful? Yeah. Like I'm it's not that I'm gonna follow these, but it starts to give me some key points that I could then also take a look at and see and cross-check with the Wolfram project. Maybe I'll just do sort of a bit of a kind of a hybrid approach to these. Uh, oh, there's someone sounds great. Yeah, thanks. I'm having trouble sometimes reading the chat, so I apologize if I don't respond to some of the messages. But yeah, that's the um, I'm pretty excited about these. So let's see. It's just I don't know. I realize that's what I truly enjoy. Kind of learn things on the wild. Um, what's the standard roadmap to learning quantum physics? I'm really interested in quantum physics and would like to learn more. However, I don't know where to start. And I and in what order should I learn things? So ideally, I'm looking for some sort of roadmap: what to learn, what physics topics do I need to know to start learning about quantum mechanics, what is the math knowledge necessary for starting quantum mechanics. My current knowledge is mostly popular science stuff, TV shows. Yeah, pretty much the same. No, I mean I do have some background, but it's not really nothing serious. Um, it's too open-ended, the question, yeah, but let's see the answers. So I would suggest that you don't do any preliminary reading and just learn quantum mechanics directly. Okay, I didn't expect that. Uh, Ron Maimon. A lot of people were like, "Ah, you gotta read these, and maybe it's better to, master classical mechanics before doing that, and just take a look at these." And, to be honest, I think there are ways to learn this kind of stuff just by jumping into the deep water and deep cold water, and then kind of like you try to learn how to swim on the way. Uh, there's not much to it. The requisite background is very primitive linear algebra, and Dirac's book, The Principles of Quantum Mechanics, and Feynman's lectures on Physics Volume 3 can be read with Wikipedia help without any prerequisites. That's an interesting take on it. The classical mechanics you need to know is not very sophisticated either. You just need to know Newton's laws, and how they come from a Lagrangian or Hamiltonian, which is covered in standard sources. You don't need so much deep stuff, although knowing Poisson brackets is handy for seeing the vestigial quantumness in the classical mechanics structure. I would suggest reading the following Wikipedia pages for a historical perspective, which helps a lot with historical literature: alt quantum theory, adiabatic invariant correspondence principle, matrix mechanics. Maybe that's something to take a look at. I don't know if I should just be taking a look at. I'm not like a heavy note-taking person, so it's not that I'm gonna share or I'm gonna produce something where I share a really well structured set of notes on what I did and what I'm planning to do, because I know that I'm not going to be able to stick to maintaining something like this. Although it would be cool, maybe a GitHub repository on what I did. That could be maybe, yeah. But I think the videos are probably good enough. Um, so alt quantum theory, that's going slow again. I don't know why. What is the CPU? Damn it, 20%. What the heck is? God. So there's this thing here. Alt quantum theory is a collection of results from the years like 1925. A lot of equations that I have no idea what they mean. But okay, that is, instead of just saving the links, I'll just save the link to this question. Maybe that helps. Matrix mechanics. This is wrongly left out of most books, and this is a shame. There's no unified presentation of the historical material. So this is more historical stuff, right? Historical stuff. Usually a waste of time trying to go through prerequisites, as they're usually boring, and most of the material doesn't end up getting used. For quantum mechanics, you need to come in knowing what is a matrix and what an eigenvalue is, and what probably you can learn that from the Iraq. Okay, thank you. I'm sorry to tell you that anything you learn on TV about quantum mechanics is useless. Yeah, that we know. Not many people in the world understand quantum mechanics, and many of those who claim to are either naive or liars. Well, that's harsh. That's pretty harsh. I bet there are a lot of scientists out there that, like, I mean, I guess define what you mean by understanding, right? It's like, yeah, you can get picky with these, but um, I don't understand quantum mechanics, but I could calculate your things. Even explain a model of the hydrogen atom. Quantum mechanics is not just understanding, it's about breaking all of your concepts. It will destroy every notion you have up to this moment. With that said, I recommend you this college-like path. I don't, for some reason, I don't like college-like paths. They're too algebra and analysis. While learning about the basics of algebra analysis, you should learn about Newtonian mechanics and Maxwell electromagnetics in that order. It almost feels like I'd prefer to take the approach of kind of just jumping to a specific topic and then, see how deep I need to go on the sides, right? Like, um, if I'd be talking about whatever topic in quantum mechanics and I come across, yeah, blah, blah, Newtonian mechanics, then I'd like, I'd take the chance to do a bit of a deep dive into these rather than like, because that's the opposite to the other answer, right? That's like you learn all that first, all the basics, and once you've done it, learn everything about Newtonian mechanics again, using the Lagrangian Hamiltonian formulation. Newtonian mechanics. So, what is the Lagrangian formulation? Formulations of classical mechanics. So these are different formulations of, oh God, three formulations. I will outline from Newtonian, Lagrangian, and Hamilton mechanics in relatively standard ways before turning some questions about them. My focus will be on the dynamical laws, since this is where much of the action lies in comparing and contrasting the different formulations. So Newtonian mechanics is the only one that comes across on introduced. Yeah, I mean, the Newtonian mechanics is what you kind of learn in high school, I guess. So the basic stuff, right? uh, you know, force equals ma and stuff like these. Lagrangian mechanics, two sets of so-called generalized coordinates describe systems of states. The generalized position and the first. Okay, so this is the Lagrangian mechanics is this whole story with positions and momentums. Okay, and in Newtonian mechanics, you need 6 n coordinates to completely specify a state of a system of n particles. The 3 generalized positions, the 3 velocities, and okay, because so Newtonian is like you've got position, you've got velocity, you've got, I guess, acceleration or something like. Oh no, just position and velocity, right? But then because we live in a 3D world and in universe, and you kind of have the six coordinates in there. And Lagrangian is just something about positions and the first time derivatives, and then generalized velocities, which it's because q usually means momentum, right? Okay, and what is the other one? Hamiltonian? Oh, and that was the thing with the matrix, right? So a special kinship with Lagrangian mechanics. A scalar energy function determines the motion, and the equations are formulated in terms of generalized coordinates. Generalized positions and generalized momenta. Okay, so the Hamiltonian is positions and momenta. Okay. Okay, cool. Yeah, that looks a bit like, yeah. The age for the Hamiltonian stuff. Okay, cool. That's something already interesting. But anyway, so let's go back to these. So learn everything. Okay, so we've got something about classical mechanics maybe that it's got to do like with the three different formulations to maybe take a look at it, right? Because this is where you have like Newtonian, then you have Lagrangian, and you have Hamiltonian, which Hamiltonian is what's kind of used in quantum mechanics, right? To some extent, at least that's a name that pops up a lot. Mm, 2 4 year project. I'm up for this, man. 2 4 year project. um, Go to lessons in my country can go without paying. Yeah, that's the thing. I don't want to go to I don't want to go back to university. I want to do this in the most untraditional way possible. Start with all quantum mechanics books, ready to learn the direct principles, and finally destroy every concept of the reality you had before starting this path. Was Dirac such a You're going to go to lessons. After all that, you will get a lot of profit by reading the EPR paradox, Bohr and Heisenberg opinion about quantum mechanics, and of course the Bell article about entangled particles. Don't get mixed up by von Neumann's principles. In my humble opinion, he was too much of a mathematician to understand the deep of Bohr and Heisenberg thinking. Yeah. The usual ways, the university is pretty much the time efficient way to go. The math and at least classical mechanics will be necessary. What is this click? Why can't people just okay, so how to become a good theoretical physicist? That's not what I want to do. I don't want to become a good theoretical physicist. Newtonian mechanics, electricity, and magnetism. I guess why is that relevant? Is it because of you bump into this when you think about like subatomic or atomic stuff? God, that feels already way more scary than the quantum mechanics 0 to 1, the quantum computing 0 to 1 project. I'm already lost. Because like this kind of mixture of go through, you know, go through the basics, go through classical stuff, and get there gradually. While I'm inclined to just jump into the cold water and then be kind of backwards. Um, it is possible to learn quantum mechanics before taking classical mechanics. That is what I did. Okay, but you do have to know what a vector space is, basis, change of basis, linear transformation, and matrix are. Then read Dirac. Okay, so if someone did it, then I can do it as well, right? You can learn the Hamiltonian point of view from Dirac. So I would say that the prerequisites are Irving Adler, the new mathematics, and Isaac Asimov, the realm of algebra. Did Asimov write stuff like these? I'm really uneducated, by the way, just as a warning if you're watching these and I don't read much. I just don't have the time that I'd like to have to do these things. But yeah, okay, that didn't tell me so much, this thing here. Just, okay, the old quantum correspondence principles, matrix mechanics. Also, I'm not so sure about these. Hmm. Oh, look at this. How can I teach myself quantum mechanics step by step? So it looks like there's quite some people interested in these as well, right? um, what? Okay, what? July 2019. I have taught myself quantum physics, but without the math. In other words, I can calculate only the tiniest bit of anything quantum mechanical, but I have some understanding of quantum physics concepts. I have also I also have a conceptual understanding of some of the equations. However, I believe that if I continue my studies, I will be able to do quantum physics calculations. I have a college degree, but no college math or physics. Actually, I've never taken any physics course in school. It's taken me about 4 years, very part-time, to get through a basic understanding of classical physics, quantum physics, a review of high school math, and a first-year calculus. I have about average talent at math, though I really enjoy it, a below average talent in classical physics, and some talent in quantum physics. Kind of feels like a description of myself. No, I do. Okay, whatever. What it takes is an intense interest in quantum physics, patience, perseverance, and at least some of the time enjoyment of the learning process. I bought books from Amazon. I like this one. Um, Classical physics first. To understand quantum mechanics is necessary to understand regular physics. This is because much of classical physics applies to quantum physics. When it does apply, you're supposed to be surprised. What the fuck? You're supposed to be surprised. If you don't know classical physics, you aren't surprised. Then it means you're not learning. Quantum physics. That's a joke, man. That's not how you learn. I studied classical physics at Physics Classroom and Khan Academy. I started with kinematics and kept going until I felt that I had the basics. With videos on YouTube, they're all different levels. I only watch the ones intended for lay people. Starting says looking glass universe and cracking the nutshell. Try to find the first videos on quantum mechanics in the series and go from there. Um, I also don't want to learn from videos because that gives you a fake feeling of progress, in my opinion. I mean, you do kind of have to get your hands dirty at some point. That's why I'm so much inclined to these. Uh, Software tools, project Q&A, live stream videos, visual summary, technical introduction, materials and technical documents, and software tools. But that feels like, it's nicely structured in here, but it feels also a bit too wild. Basics from the models, typical behaviors, limiting behavior, and emergent geometry, blah, 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 blah. Potential relation to physics. What I like about these is that it's really computational. It's close to computational stuff. It's like really computationally related, which is something I really like, right? I did study computer science, although I wouldn't say I'm a rock star at it, but it's something close to my heart. So, and as I said, I don't really care if that's a BS project or not, or if this is going to succeed or not. But I'd like to use it as a frame, to learn quantum mechanics in a way that, like, I have to constantly challenge myself what I'm trying to do, right? But I don't like that. Still feels like there's not enough guidance, but it might be good. That might actually good. Functions and the tools and so are. First of all these tools freely accessible, or do you have to somehow become a member or something of these? Okay, that didn't lead anywhere, did it? Oh no, it did. It's a computational essay. Okay, so that's probably dynamic stuff. Your first universe, symbolic representation, multi-way systems, hypergraphs. Okay, that's cool. So there's actually some interactive stuff in here. Um, Man, I'm just I might just I might just do these. That just feels fun. Like, learning quantum mechanics, like almost like rediscovering it with this model, even if you're, as I said, you kind of clash against a wall and you realize that just things don't match, at least you're learning, right? Um, Registry of notable universe models. Yeah, I know there's a lot of clickbaity stuff, but I guess that's fine. That looks nice. Yeah, I think I'm just gonna go ahead. This is all like it's 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 the same story. It's like, yeah, some people tell you you don't have to just jump into it and learn, but it feels not so much practical. Um, I don't know. I have the feeling I haven't thought through this maybe well enough. But what else? Even if you learn like calculus, go to hell. Oh no, I don't want to go to Quora. That's just it's like medium. It's just but that's a medium one. Can anyone learn quantum mechanics? This is all just stuff like just it's just clickbait. Where does a math person go to learn quantum mechanics? I'm not a math person. That's all the first page of Google offers me. Let's learn quantum mechanics video. Great. 4 hours. Great. Scott Young. Probably someone important. I don't know. X, learn quantum physics and mechanics with online courses. So let's see, what do these programs do? Like, no, Quora, no. What? This one. Oh, WikiHow. Oh, WikiHow. That's a good one. There's a WikiHow on this. Um, First, Planck constant. Start with learning about the physical significance of the Planck constant. Okay. In quantum mechanics, the quantum of action is the Planck constant, usually denoted as h. Likewise, for interacting subatomic particles, the quantum of angular momentum is the reduced Planck constant. Blah, 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 blah. He looks worried. That's funny. What time is it? Okay. Uh, what? What did I do? Learn about massy particles. I like how the pictures are just like a guy reading a book and then they just they just have the title in here. Oh, massive particles go through a classical quantum transition, even though the free electron displays. That's funny, man. Novel ideas. Be across the novel ideas presented in quantum theory. What does it mean, be across? Why does the number one when this is one, this is two, and this should be three, right? Whatever. Particle and wave duality. Oh, they've gone one step forward with the images in here, but it's the same image. Study the concept of particle and wave duality. Uncertainty. Study the uncertainty principle. Wave function. Learn about the wave function. Schrodinger's equation. Understand the Schrodinger equation. That sounds like an easy step. Oh god, quantum superposition. We know that already. Check. Ignore the classical picture. Check. Like community and Q&A. Okay, now that's just like Jesus Christ. There's just so many crap online. No, electrons cannot split as far as we can tell. It's a good fun reference. I'll keep it. I like it. That's a good one. It's definitely a good one. Um, yeah. What is the best way to learn quantum mechanics? Math overflow. I like how this question is posted across like many disciplines, right? Math and physics and stuff like these. Are we books quantum? What? I'm not. How to learn? Oh crap! Google, what are you doing? I want to go to page 2, which is something I usually wouldn't do. So this is cell study guide. Um, we could watch that. It's 10 minutes, but I don't have 10 minutes now. Oh, maybe yes. Um, Learning quantum mechanics by yourself for cheap, and even if you don't, let's see. Can we watch that? See if hopefully the volume will come through. I don't want to. I don't want these to be too loud, and of course, there's a commercial. Oh, that's the Looking Glass universe. So actually, they were some of these, some of the sources were referencing these, right? Oh, there's no audio. What's wrong? Manuals. Okay, I'll watch that later. Uh, Linear algebra, but that seems like the same story, right? Like learn the math, learn the things. which is fine. I mean, I'm not saying that's not the right. I'm not saying that doesn't work. I mean, it works. It worked for everyone in physics, probably. It's like I just would like to do it a bit differently. I'll watch that later because I'm not getting the sound through for some reason. Because the desktop audio is disabled, I think. Uh, not to kill your ears in case of an accident. But let me just take a. Let me just keep tabs on this. Um, Reddit. Oh, that's gonna be a fun one as well. And I think we'll leave it here. I think I'm gonna go with the Wolfram project. I know I'm biased because I almost like just want to do it for fun. I'm like, but I'm still thinking maybe there's another way to approach quantum mechanics. But I think it's just kind of fun, hands-on, and um, in a way, I think will create the right amount of pain. You know what I mean? Uh, I love listening to smart folks talk about it. I wanted to try and understand it holistically. So I bought myself a book on quantum mechanics. Amazon reviews promise was great for beginners. No prior knowledge needed. Lies. Lies. I like how dramatic this is. It's like, God, lies. They lied to me. I opened the book and on page 2 there's nonsense. Page 2. Oh God, that's good. That's fun. To do physics, you want to be pretty competent at algebra, geometry, and calc different equations. This is like, fuck off. Hi, friend. I'm in the same boat as you. The two resources, that's 2 years ago. Dr. Physics 8's videos on quantum mechanics here. Blah, 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 blah. Nuclear physics, taking an online course. And oh God, he looks scary. Explaining the double split. I don't like this. Just go away. Go away. Build on your team terms from anywhere. What is this? It's a fucking commercial. Okay, that's all. Yeah. Good. And not good, but good. I think if page 2 does not give us an answer, then we'll go with Wolfram's project probably. So stay tuned for more. Yeah. Um, yeah, we'll do that. To be honest, I really don't know where to start either, right? Because like they're doing their own thing, right? There's this working sessions going on and they're doing their own thing. And so I think this is a bit more like that's a framework and people can contribute to these, people can play with these. Um, and it almost feels a bit stupid to kind of do a full introduction to these, but because it's a bit of this, it's the same thing, right? Like learn the basics and then kind of, but maybe this is a bit more compact. So it's like learn the basics to work with a model so that you can kind of go ahead and explore quantum mechanics with these. But Wolfram helping gallery archives materials. So Wolfram physics project quantum mechanics. Is there basic concept quantum mechanics, Wolfram physics? Maybe that's a starting point. Oh, actually, there is. Okay, cool. So in the introduction, there is the potential relation to physics. So there is basic concept quantum mechanics, quantum formalism, quantum measurement, operators in quantum mechanics. Oh, wave particle duality. Okay, so okay, good. Local gauge invariant. I have no idea what that means. Okay, but there is like a good structure in here. Okay, that's probably a good starting point to just go through these and maybe read and play with these tools. So maybe what I'll do is I'll first kind of get set up with the tools and then start reading that. Oh, so QStudy is sharing a link, a PDF. Let me see if I can copy that from OBS somehow and click on it. Oh, there you go. Thanks for sharing these. What is that? Sorry for my internet speed. It's got nothing to do with the internet. It's just my computer does funny things sometimes. That's a big PDF. HCD. Oh, I hope that's legal. Isn't that a book you're supposed to buy? It's 500 pages. Modern Quantum Mechanics, second edition. Um, yeah. I'm not sure I'm ready to digest a book like these. I feel I almost wanna get hands-on first and do a bit of a kind of explore, like drop and explore kind of approach. I just made up this name, but yeah, and then maybe approach books. Yeah, but thanks for sharing. That's definitely something that I'll keep in mind. Uh, Let me just how do I copy this link here? No, that's the YouTube stuff. Whatever. So I think I'm gonna go ahead and try. And again, it might be a failed start, right? So, but I don't care. I mean, that's a long journey. Gotta start somewhere. I just feel like the traditional way is just a bit boring. So, and again, I don't care whether you like the Wolfram Project or not. Like, I know there's a lot of criticism around it, but I think it's a good setup to exactly what I said, right? Challenge and make sure like so I'm gonna be learning something that I don't know if it's BS or not, the way that it's written here. So that's gonna help me, I think, stay some sort of have the state of awareness that I might have to trash things from time to time mentally. Cool. I'm really excited about these. Really excited about these new chapter of Uncertain Systems, Project 3. I'll kind of be wrapping up the other two projects, but still the stuff with the entanglement simulator thing, that's something that I'm going to keep working on the background, sort of off stream. Might do a couple of streams, from time to time, just to kind of, give bigger updates once I release sort of 1.0, the 1.0 version, which should come out soon. And out of that, we'll build some, learning notebooks for algorithms and stuff like that. So I'll definitely do some more work in there. But this seems like a nice thing to kind of get my head around already, like to kind of get started at least, because I think the starting is always the difficult part, right? Get used to the tools and play with these things. That's going to take a while. But that seems like about right, and I am actually quite looking forward to it. So if you want to join me in learning quantum mechanics like these, then do this at your own, risk. Um, and let's just have fun doing it. Yeah. See you next time.